Today's focus will be on calculations of potential and kinetic energy, but we will be doing a little bit of review about what potential and kinetic energy is first. So what is energy? The energy is the ability of an object to do work. There are two main types of energy. We have potential energy, which is stored energy, and we have kinetic energy, which is energy in motion. And remember, within those two types of energies, you have different subcategories like chemical and thermal and nuclear and gravitational and things like that. So first, we're going to focus on potential energy. Potential energy is the energy that is stored and is waiting to be used later. So this would be your elastic energy, right? It's stretched out, it's not really doing anything, but it's storing that energy. And you've got potential energy in this picture due to gravitational because of its position of being higher. So it is a potential energy is energy to an object's position or its shape. So for example, when it's elastic, it's stretched out, or if it's a spring and it's stretched and it's pushed down, that is different types of stored energy. The key to this though is that potential energy in this slide is that mass times height times gravity is equal to your potential energy. This is the formula that you're going to absolutely need to understand. Mass, for this to use this formula, has to be in the unit of kilograms. Height has to be in meters, and gravity, we're going to be dealing with Earth, so we are doing 9.8 meters per second squared. If you are on some other planet, then you would use their constant for gravity. So first problem is find the potential energy, so I'm asking you to find for that, of a 20 kilogram bag of dog food elevated 5 meters above the ground on a shelf. So the first thing I want you to do with any of these formulas is I want you to write out all of the different variables. Okay, and then what I want you to do is fill in any of the information that we know. So first off, I'm asking you to find that, so I know that is going to be my question mark. Okay, then we've got meters. Okay, so what is we've got mass. So this M stands for mass. So what is my mass? It needs to be in kilograms, which it is, and so we would write down 20 kilograms. G stands for gravity, because we were assuming that we're on Earth. We're going to do 9.8 meters per second squared, and your height has to be in meters, which it is, and that would be 5 meters. You do absolutely need to write these units down. Okay, you will be getting points for writing the number down and the unit. Each one is extremely important when doing these calculations. So we are trying to figure out potential energy. When you do this multiplication problem, just to let you know, potential energy's unit, anything energy for this class will be answered in joules as its unit. How do you spell joules? It's Joules, okay, and its abbreviation, or its abbreviated version, is a capital J. So if I ever am solving for energy, my unit will be in joules. So now all you have to do is plug and chug this. So my potential energy equals my mass. What was my mass? Well, according to this, my mass is 20 kilograms. So I'm going to do 20 kilograms, and yes, you absolutely need to write this unit. You will be getting points for writing out the unit every single time. Then it says times G. So I'm going to do times my G, which is 9.8 meters per second. This is called plugging and chugging. What that means is you just plug in the numbers with the units, and then chug on your calculator, and then there you got your answer. Times my H, which is 5 meters. So I'm going to times by 5 meters. Now all I have to do is get out my calculator. I'm going to take 20 times 9.8 times 5, and those units will translate to actually joules. So kilograms times meters per second squared times meters actually translates to the unit of joules, and so you get 980 joules is your final answer. Make sure you answer with a unit. Okay, so let's try a different practice problem. So find the potential energy of a 65 kilogram climber at the top of Mount Everest. Okay, so now we're going to plug into our different units or variables: potential energy, mass, G, and H. So we've got potential energy. Once again, I'm asking you to solve for it, so that's going to be my question mark. I've got my mass, which is 65 kilograms. So I'm going to write 65 kg. Yes, once again, you cannot be lazy and you have to write that kg. At the top of, and then I'm going to do my G. My G, because I'm assuming Mount Everest is on Earth, which it is 9.8 meters per second squared. And then your height will be 8800 meters. Okay, so now I'm ready to plug into this formula. So I've got my potential energy, which is what I'm solving for. That equals my mass, which is 65. Yes, write the kg, times my G right here, which is 9.8 meters per second squared. That is a point, just covered it up. And then times H, which is 8,880 or 8,800 meters. And so once again, all you have to do in your calculator is 65 times 9.8 times 8,800. And when you get that, you get a huge number of 560,5600. Make sure you add your J for joules as your final unit for your potential energy, and you get all those points. So that's the formula for potential energy equals mass times gravity times h or height. Okay, so what is the formula for kinetic energy? Because kinetic energy is not the same. So kinetic energy is energy that is in motion. The formula for kinetic energy is kinetic energy equals 1/2, literally the number, times mass times speed squared. Now you have to be in certain units in order to do this. So your kinetic energy, which is joules, equals 1/2 times your mass, which has to be in kilograms. Notice I'm just writing down the units right now, times your meter or your speed squared. And we're going to be in meters per second, and we are squaring that. Okay. What I also want you guys to note is this lovely graph. Okay. What I want you to really focus on is when you look at your kinetic energy and you look at your potential energy. I'm going to do it in black. When we look at these numbers, when your kinetic energy or when your potential energy is at its most, your kinetic energy is at its least. And notice that they keep transitioning between kinetic and potential. That is a constant. So your amount of energy stays the same. It's just going to transfer from being kinetic to potential based off of this roller coaster. So what we're going to do is when it goes to and TME stands for total amount of energy. So we start at our biggest potential, and notice your biggest height, and now you are going down. Okay, and now as it goes up, it loses its kinetic energy. As it goes down, it gains kinetic energy. So here it's going to be gaining kinetic energy. And then when you're going up in height, you gain more potential energy. When you go down, you gain more kinetic energy. Okay, so let's try to revisit this again. Okay, so when you look at this, at the bottom, it should have its most kinetic energy, which it does, and no potential energy because it has no height. When it's at its top of its peak, it should have the highest potential energy and the lowest kinetic energy. So notice that it's keep on transferring between kinetic and potential and kinetic. All right, so let's do this kinetic energy equation. So kinetic energy, because of its variables, deals with both mass and volume. Both of them will affect it. So if I change its mass, then I change its kinetic energy. If I change its velocity or speed, I am also changing its kinetic energy. All right, so here's the first problem. What is the kinetic energy of a 44 kilogram cheetah that is running at 31 meters per second? So as with the potential energy, what I want you to do is write down your variables. So KE, 1/2 is not a variable, that's a constant, and then it's M and V. So kinetic energy is what I'm solving for, so I'm going to put a question mark. My mass in this case is 44 kilograms, and my velocity is 31 meters per second. So now I'm going to plug and chug, and notice once again I did write all my units. So now I'm going to plug and chug into this beautiful formula. So KE is what I'm solving for. That equals 1/2 times M, which is 44 kilograms, times V, which is 31 meters per second squared, and I'm squaring that, sorry. Notice I am squaring the 31. I am not squaring that 44. That squared only is associated with that V. So when I type into my calculator, what I'm going to do is 1/2, so 0.5, times 44, okay, times 31 squared, okay? So remember, you're not squaring the 44 or any of that. You're going to type in literally 0.5 times 44 times 31. Do that caret, or you could do just that squared button on your calculator, and then press enter. And you should get 21,142. And as with potential energy, kinetic energy's unit is still joules, the capital J. So let's try the next one. What is the kinetic energy of a 400 kilogram elevator that is descending, meaning going down at 5 meters per second? So as with every problem, you are going to have to write down all of your variables that you know. okay, and all of the ones that you don't know. And it'll help you figure out how to use this formula properly. So kinetic energy is what I'm solving for. My M is 400 kilograms. So I'm going to write down 400 kg. Once again, notice I am writing down units. My V, or my speed, is 5 meters per second. So now plugging this into the formula, in which I'm going to have to show this work, KE equals 1/2 M, which is 400 kilograms. Yes, you do have to write the units initially, times my V squared, so 5 meters per second, put parentheses around it, and then put that squared on the outside. Now, if you want, after that, you can drop the units because it does get a little confusing for students. So you're going to do 1/2 times 400 times 5 squared. Okay, so typing that into my calculator, I'm going to do 0.5 times 400 times 5 squared. Okay, and in this I get 5,000, and that would be joules, or capital J as my unit. All right, hopefully you have an understanding of how to do some calculations for potential and kinetic energy. Keys for this is you have got to write down your variables with their units, and then you have to show all of your work, and when you're showing your initial work, you absolutely need to write down your units. You will be getting points for all of this part. Have a great day.